Hi everyone, today we are finishing up activity 16 by looking at the reciprocal trig function starting on page 219. Definitely going to want your unit circles here handy. The reason I also bring this up with the unit circle is because we talked a lot about what sine, cosine, and tangent in the previous lessons, and now you also see these reciprocal trig functions of secant, cosecant, and cotangent listed. So we're going to start talking more about those today on page 219. So we've talked a lot with using the unit circle and how, sine is associated with your y values, cosine with your x value, tangent is y over x. And again, that stems from the fact that our r value on the circle is 1, so that's why it reduces. Today we're going to go back to talking about, just in general, that this is y over r being your radius. In this case, that may not be 1. We have x over r, and then tangent was y over x. Well, your reciprocal trig functions are the flipped fractions of these. So instead of being y over r, it is now r over y, r over x, and x over y. And the idea of the reciprocal is you're just flipping the fraction. So looking at some of these values, we now need to use that information to find the values that do lie on our unit circle here. So secant is the reciprocal of cosine, aka we need to flip the x value to now be in the denominator. So normally at 45 degrees, we know our x value is square root of 2 over 2. So now it's 1 over that value. Now, we do not like to write this quite so ugly. So if we flip the fraction to multiply it by the reciprocal to get this in the numerator, we see this, which is still not great because we, again, normally don't want that radical in the denominator. So really we get 2 square root 2 over 2, which just cancels to be a final answer of the square root of 2. Okay. Cotangents, again, are the opposite of your tangents, so they will be the x value over the y value. Now, in this case, 2 pi over 3 is located at negative 1/2 square root of 3 over 2. So this time when we create our fractions, it's going to be the x value over the y value. Denominators cancel, and this is going to look really similar to what we were doing before with tangents. And we know that this then becomes negative square root of 3 over 3. Okay. 270 degrees is at 0, negative 1. So secant of that is, again, 1 over the x value. So in this case, 1 over 0, which is undefined, is our final answer there. And last but not least, the cosecant of 7 pi over 6. Well, 7 pi over 6 is located at negative square root of 3 over 2, negative 1/2. And we know the cosecant is the opposite of the sine, aka 1 over the y value. So if we take the y value here of negative 1/2, we need to essentially flip it. Now, again, anytime you are taking 1 divided by the value, it's really the same thing as just flipping the fraction to now be this, which nicely does not need to be simplified beyond just being negative 2. Okay. Now, moving on from there, we also want to talk about finding all 6 of our functions given a reference triangle. So here, they're telling us we're at 4, negative 3 in the example on page 220. And 4, negative 3 is a value here in the 4th quadrant. So using Pythagorean theorem, we know that our hypotenuse is 5, and we can figure out the values then of our 6 trig functions using that information. So a picture is often helpful with these sketching it in. So on page 220, if we look at try these A, we know that negative 5, negative 12 puts us into the 3rd quadrant, right, left and down. And if we use Pythagorean theorem to find our value of the radius, or if you know your Pythagorean triples, you know that this comes out to be 13. So now using this information, we can find the sine, cosine, tangent, and the reciprocal functions of this theta value, okay? Because sine is the opposite over the hypotenuse, aka your y over your r, which in this case, x, y, and r, or again, opposite adjacent hypotenuse, we would have negative 12 over 13. And then the cosine of this value is going to be the x over the r. So in this case, that's going to be negative 5 over 13. And then last but not least, the tangent of theta is y over x. So in this case, negative 12 over negative 5, which will just actually be positive 12 over 5. Now, the nice thing here about your reciprocal functions then is that you just have to flip-flop those values, right? So in this case, the cosecant is the opposite of your sine value. So we're just going to flip that. We are now at 13 over 12, still stays negative, right? And the secant is the opposite of the cosine. So in this case, again, it still stays negative, but it's 13 over 5. And last but not least, the tangent will still stay positive. And in this case, it's now 5 over 12. So again, we could see the relationship between the reciprocal and its function. Right, you see these here, how they're just flipped fractions of each other. The sign will stay the same because, again, it's in quadrant 3. All right, so same idea here with 2 comma 4. That's actually a quadrant 1 value, so everything's positive, which is nice. This is not, unfortunately, a Pythagorean triple, though, so we end up with 20 is the r squared, which means our r is the square root of 20, which we would call to square root 5. Okay, so that's our hypotenuse this time, which means the sine, cosine, and tangent. So we have y over x, or aka the opposite over the hypotenuse. So that's 2 over square root 5 if we reduce. But again, ideally, we like to make sure that we rationalize. So multiply top and bottom by the square root of 5. You get 2 square root 5 over 5. And then here for cosine, we end up with 2 over 2 square root 5, x over hypotenuse. So again, after we reduce and rationalize, square root of 5 over 5. And last but not least, the tangent is the y value over the x value, which nicely reduces to just be 2. Okay. So for our secant, cosecant, and cotangent, then I actually would kind of recommend you go back to the beginning then and look at these when you flip, because for the cosecant of theta now, we're going to flip-flop the sign, and when we reduce, we end up with the square root of 5 over 2. For the secant, then, we're going to look at the cosine, which was really 1 over square root of 5 is what it reduced to be. So now it's the square root of 5 over 1, which is just the square root of 5. And last but not least, the tangent was 2 over 1, or we could even say go back to the cotangent, then would either be 2 over 4 or 1 over 2. So it reduces to be there. Okay, so these would all be the answers, all 6 again, and then make sure that you simplify. Again, sometimes it's nice to go back to the beginning with these ones, because then you didn't have to unrationalize the rationalized ones. Again, going back to the beginning of the picture. Okay. And then this last piece here, if you look then on page 221, again talks about these examples and finding the values. Now notice they give us a couple of things. They give us an original function and then some specific information, in this case about the cosine, because that's going to help us limit to what quadrant we are in to be able to figure these out. Okay, now looking at one of the examples not created, this one they're telling us about the value of the tangent and the fact that it is located in quadrant 3. So start again by drawing a picture. Tangent is y over x, so we know that our y value is 4, our x value is 3. But because we're in quadrant 3, we actually know that both of them are negated officially. And using Pythagorean theorem, our radius here is 5. So if we're looking for sine, cosine, and tangent of these, well, first of all, tangent they gave us was 4 over 3. Sine then is opposite over hypotenuse, or y over r. Cosine is x over r, or adjacent over hypotenuse, which means then the reciprocal functions, all 6 trig functions are what we're looking for here. That means that cosecant is the flip of that. So instead of being 4 over 5, it's now 5 over 4, still stays negative. Secant is the opposite of the cosine, so that's going to be negative 5 over 3. And cotangent in this case was 3, is going to be 3 over 4 since it was 4 over 3. Okay. So again, knowing this information is super helpful to us, especially when we have part B here, because this time they're telling us that the secant is 6 over 5. Well, the secant is your r value over your x value, or hypotenuse over adjacent, however you want to think of that. Now they're also telling us that sine is less than 0, aka your sine value is negative. So we know we're either limiting this to be in quadrants 3 or 4, but because the secant is positive, aka the cosine is positive, we know this has to be a quadrant 4 value, because otherwise the cosine is negative in quadrant 3. So that's why quadrant 4 is where we know this is going to have to be based on this information. Okay, so when we draw this in, we know the radius is 6, the x value is 5, and whatever this y value is, it's going to be negative because of the fact that we're in quadrant 4. And when we solve on this one, 36 minus 25 is 11. So we know that the square root of 11 is the y value, that again is negative based on the quadrant 4 location that we deduced. And then filling out our cosine, sine, tangent. Cosine is your x value over your r value. Sine is your y value over your r value. Tangent is y over x. And then from there, the reciprocals of secant, cosecant, and cotangent are going to just require us to flip those. So the opposite of the cosine now is 6 over 5, which is good. They actually told us that one. And then the opposite of the square root of 11 over 6 is 6 over square root 11, which we know we will have to rationalize. And then last but not least, we have negative 5 over square root of 11, which is negative 5 square root 11 over 11 after rationalizing. Okay. All right, so those would be all 6 answers for that one as well. And finally, talking about these then, again, really important to know where things are positive and where things are negative to find these exact values as well. Because again, setting up then the pictures here will help you find out what the other values are going to be based on these, which we will work more with in class. Okay. So again, having this piece of information copied down, very crucial to, again, kind of helping you figure out where am I at on certain pieces. All right, again, we'll work more with this in class. Thanks, everyone.